All right, welcome to another lesson in computer science. What I'd like you to do is to download driving putting.txt file, and that's the data file that we'll be using. So I'll go ahead and download it as well from our classroom, and you can click on these three dots to open in a new window, and that usually makes it easier to download. And so then I can press the download button. And I'll just save it into my downloads. I have the ability to direct it, but some of you automatically get your stuff in downloads, so I'll show you how I do that. All right, we're going to make a new project called Drive Putt. So just make new project, call it drive_putt. And from there, I'm going to go ahead and bring in a file from my downloads, and I'm going to store it in that folder. All right, so in my downloads folder, you can say I have it here. I'm just going to right click on it and say cut and move it to my new folder that I just created. Called Drive Putt, and I'm going to paste it there. So now I've got the folder, the file right where I need it. All right, let's go ahead and take a look at our data file. And we've got some new issues that we get to deal with. First of all, let me explain what this data file is. This data file is looks like the A, and Aaron got cut off. Let me fix that. This data file is an alphabetical listing of PGA Tour golfers from 2019. The first two words is their name usually, but sometimes you'll notice that there are more than two words, like with Bo Van Pelt. You got CT Pan. So while two is the norm, it's not always that way. I think we have some juniors here. Rafa Cabrera Bello has got three words to his name. So we're going to have to deal with that. Oh, that's a problem there. That little character. So I'm just cleaning up the data file here. So you may want to fix that. Sebastián Munoz must have had a foreign language file, that character that I didn't process correctly. But I don't think that'll hurt anything. Okay. So that looks pretty good. Now, you'll see after their name, there's a number. This is their average driving distance in yards. And then we have a number here, which is called strokes gained putting. Now, typically we talked about when golf, you think of strokes gained as being a bad thing, but in the terms of strokes gained putting, you want it to be a big number, I think. Right. So you actually want it to be a positive number. What they mean by strokes gained putting, that's how many strokes you actually improve over everyone else based just on putting. So if you make a lot of putts, then you're gaining on the field. So you can think of those as being like strokes that you saved in golf, because you usually want the lowest score wins. So you could see, let's see here, Graham Dillette, I think, is a notoriously not great putter. Yeah, he's at -16, so he's losing over the course of, I think this is over the course of like a year total. That's how many strokes they figured that he lost, that he should have been able to score for the year. Now, we could have possibly done better if we got the average strokes gained putting, but that's okay. Yeah, probably should have had the average, but this is the data that we have, so that's fine. What we're going to do now is we're going to work on processing this data and looking at different things we can do with it. So let's make a new class, okay? And I want you to call this class GolfStats. And let's open it up and go with it. So first thing I want to do is I want us to work on getting all of the numbers in a list. So let's start with importing java.util.scanner. And we'll do java.util.ArrayList. We're going to use an array list. We also need to use a file. So we'll say java.io.file and java.io.file not found exception. Okay? And really, I like to use a scanner and be done with it. Like I prefer to scan in the data and put it into something that is more easily usable. A scanner can only go in one direction. Once you're done scanning the file, you have to throw it away and make a new scanner. But if we can put in things like lists and stuff like that, we can do a lot more things with it. So let's go public class golf stats. And we're going to, the first thing we're going to do is we're going to work on trying to figure out the average driving distance on tour. I then want to find the longest driving distance on tour and shortest driving distance. So in the data set, you'll notice that we had that issue that it's not always, it's not always 1, 2, third thing that we scan. There are some things there are lots of different ways that we could handle that. There are certain classes, certain methods in the character class, like character.isDigit. So we could scan while the first character is not a digit. But what I'm going to do is actually just work from the back of this line, and this element here will be the last element in the line, and this element is the second to last. So in order to do this, we're going to have to use something called arrays, which is something we haven't used a lot of. We've used more array lists. Let's take a look at how an array works. So an array, unlike an array list, cannot be added to or subtracted from. It's very permanent in its size. So let's say that we have a string array. And what you do is you say string bracket array, and I'll just call it R. And you say something like this, and then you can give it an initializer list, like A, B, C, D, and E. So now what I've got is an array of strings, and I can actually look at it by saying R bracket 0. And so this is very similar to how lists work in Python. So you might be familiar with this idea. The first index is 0, the next index is 1. But there's also something called r.length, which is the length of the array. So I typed in 5 words, if you will. Each one of those is a string, and that's why the length is 5. Now, if I say r bracket 5, I'll get an error because that's outside of the index for length 5. Because if you have a length of 5, the first index is 0, then 1, then 2, then 3, then 4, which makes 5 total. But if I subtract 1 from that length, then I'll get the last number in our last word in this case. If I subtract 2 from it, I'll get the second from the last. Let's use that to our advantage. All right, we're going to write public void run, which will throw a file not found exception. We just need that because we're scanning a file. I know it's annoying, but that's just the way it is. Okay. And we'll say scanner F. I'm just going to call it F for file equals new scanner. And I'm going to do something kind of interesting. I'm going to create a new file inside my scanner constructor. Usually we make a new file object and then we put that object in here. But if all I'm going to be doing is loading the file, I can just load the file inside the scanner. So this is the new way. And so use that. Here was our old way, okay? We said file, maybe file equals new file, driving, putting, dot text. And then we'd say scanner F equals new scanner file. Well, this is the only time I ever use that file, so I don't need to keep what we call a reference to it. I can just use it anonymously. I can take this right here and just replace that with it, and it does the same thing, which is exactly what I've done here. Okay? If you don't like doing things two at a time like that, feel free to do it the old way, but that's the way I wanted to do it. And then we're going to say while our file has more to scan. While f.hasNext. While it has next, we're going to do more. And so I'm going to be introducing you to a new kind of thing. String line equals f.nextLine. So this is going to take in the entire line of data. And it will take it in as a string. So for example, starting at the top, it's going to go the whole thing. All of it. I'm now going to create a line called string array or str equals line.split. And in Java, when you use split, you have to tell it, it doesn't have a default, you have to tell it the split around a space. So this is going to create an array for us. Let's take a look at the interactive shell, how that works. So last time I created the array using what's called an initializer list. Let's take a look at how to use split. A, B, C, D, E, F, G, H, I. That's my string, and then I'm going to call a method .split on that. And I'm just going to inspect it. You'll see that EFG did not split apart because that was all one word, right? But all the rest were split. Notice there are no spaces in our array because whatever you split around doesn't get included in the array. That's where it divides it. So I got the A, skips the space and makes a new spot for B, C, D, E, F, G, H, I. All right, well, that's really helpful for us because now we know every time in our data file that the last number is the putting and the second to last number is the driving. So we just need to get the second to last number. But there's something else that we have to deal with. Those things are now strings. We need to parse them. So we're used to being able to use a scanner and say something like f.nextDouble. But now we have to do it the harder way. We have to actually parse it. It's not too bad, though. All right, so I'm going to say double drive dist equals string array. Oh, you know what? That might be it. Let me do it in two different sets, actually. Okay, so let me say int len is equal to strarray.length. That is the length of the array. Unlike a string length method, it's not a method. It's just a variable. You could see that in when you inspect it, you'll notice that we have the array and this public variable length that tells you how long it is. All right, then what I'm going to say is double driving distance equals double, capital D double. It's a class called double, and this class is used to handle objects that are, instead of double primitives D, it's objects, but it has a static method called parseDouble. So there's double.parseDouble, there's integer.parseInt, there's boolean.parseBool. Basically, any primitive you can imagine, it has a parse function. So to parse something means to separate out, to read it, to like get to it. Like if you were to scan a document and find all the numbers, you're parsing all the numbers. So we're going to parse the double that is at string array bracket len minus how much? Len minus 1 is the last item. Remember, the driving was the second to last item. So yes, I could have skipped line 11 if I were to just take that and put it here. But I find people get a little confused why I'm saying the array name twice there. So I eventually I expect you to get to that point, but I wanted to do it on 2 steps. First, I got the length. Then I used the length to get that value. Okay, what I want to do before we start putting this in a list is I want to print. It's so important when you're developing your programs that you develop your programs iteratively, that you have a goal. You say, okay, let's make sure we can get the driving statistics. Let's do that and make sure that we're reading it correctly. Because you can do a program and everything in the program be great, but you're just not reading the data properly, and you think that your program's wrong when it's actually just something wrong with your scanning. All right, so I'll make a new instance of this class because this is an instance method. We got to call it on the instance. Okay, to me, this looks like we have got this data fairly well. I don't see any rogue kind of numbers or all 3-digit numbers. And obviously we got the numbers correctly because we would have gotten an error if we tried to parse something that wasn't a double. All right, so I'm happy with that. I'm going to put it in a list now. Let's make our list an instance variable. Now, my scanner was created inside the run method, so I don't have access to my scanner anywhere else, which is actually fine because I just want to use my scanner to load stuff up and be done with it. But I'd like to have this list of data in several different places. I'm going to make it a field, an instance variable. I'm going to say private array list. And with an array list, you cannot do this. And I don't want to bore you with why you can't put primitives. Just know that's why they made that. In general, if you don't need an object, use lowercase double, because it'll be easier for you to deal with. There are some nuances to the objects, and we'll discuss that as we come to it. Private array list double, and then I'm going to call this driving data. Okay. And since we have an instance variable, we'll go ahead and write a constructor. Remember, if we don't write a constructor, Java writes one for us that does that. Well, actually, technically, that does that. In this case, I'm not subclassing anything. I'm just subclassing objects, so it does nothing for me. So it hides this from us. We don't have to see that. But, and we don't need that. But we now have an instance variable, so we better go ahead and initialize it. So all we're going to do is say new array list. Now, used to you had to do that as well, but they now let you just do that. Okay, but I'm instantiating it. So here was the type. Here's me instantiating the ArrayList class. So now driving data is an instance variable. It'll be an empty list. Now instead of printing, we're going to add. You should remember how to add to an array list. You add to an array list by saying .add, and then you put what you want to add. Now this is what I'm adding, though, is a lowercase d double to an array list of capital D double. Well, there's a process in Java called auto boxing. So it's going to auto box, meaning to box like wrapper is to take a primitive and wrap it in an object. So it's going to automatically convert this to the capital D double for us. Let's compile and run. Okay. So right now, when I make a new instance of GolfStat, watch what it gets made. I get that array list. Before I did that, I didn't have it. If I inspect it, you'll see the size is 0. I have nothing in it, right? All right, so let's run our run method and inspect again. And you'll notice that my driving data now has 284 items in it. Different doubles. Okay? All right. Okay, so after we've done that, our goal is to figure out what is the average. So we're going to do that after this run here. Let's make a method that does that. So public void print average distance. Now, because we declared our array list outside of any method as an instance variable, I have access to it down here. So to find the average value of a list, we need to add all the items in a list, then divide by how many there are. So you need to use the .get method to get, and you need to use a for loop with I. You need to get the ith item, add it to a variable called total, and then divide it by the size of the list. So I'm going to ask you to do that on your own, and then we'll check back together. So your goal is to write this method that finds the average value of driving data. Okay, so this is what I would do. First, I would make a double called total. That I would start it at 0.0. Then I would use a for loop for int I equals 0. I less than the length of my list, which is driving data dot size. And notice that we want I to be strictly less than it, because the last index is 1 less than the size. And we'll make I increase by 1. Okay, so what we're going to do is we're going to take the total. We're going to increase it by driving data.get I. So we're going to get one at a time each item in the list, and we will increase the total by that value. All right, once we're done with that, we'll say system.out.println our total divided by the driving data.size. And that should be it. Be real careful anytime you divide in Java. Make sure that if you want a true number, make sure that at least one of them is a double, which total is, so we should be good. All right. Let's run it. So I'm going to instantiate new GolfStats. Now, this is important. We need to run this first so that we scan the data. Maybe we need to call that method something like run data file or input data. Now you can print the average distance because now it's filled up. And you can see 295.6-ish is the average yards of drive on the PGA Tour. All right, now this is getting a little bit annoying to have to run several different things. So we're going to kind of fix that right quick by making the public static void main method string array arcs. And what we're going to do here is we're going to put exactly everything we just did. First, we right-clicked on it, we made an instance. Then we right-clicked on that and we ran it. Then we right-clicked on that and we called print average distance. So first, we're going to make an instance of this class, GolfStats. I'll call it GS, equals new GolfStats. Do I need anything in the parentheses? Well, let's check the constructor. No, I don't. Then we said gs.run to load the data. I'll add a little comment there. Whoops, what's wrong with you? Oh, there's our unreported file not found exception, must be caught or thrown. We'll add it right here, so we'll just throw it. There is another thing you could do to handle it internally, but I don't want to go over that right now. And, okay, and then after that, let's do gs.print average distance. So let's see the difference that does. I now have a static method, so I have an option not just to do a constructor, but I can run my main method. And it does exactly what we did before. Excellent. All right. The next thing I'd like to do is I would like us to find the smallest value. So let's write a method that finds the smallest value in the array list. Print smallest distance. So the smallest distance that is going to be found by starting with the first number in the list and then moving down from there. So let's take a look. Let me just put that in a picture that we can kind of talk about, because this algorithm is so important and one that can cause people some confusion. So I'm just going to get a quick snapshot there, and I'm going to add it to a Paint document so I can kind of draw on it a little bit. All right, so what we're going to do, and I know this is not the full list, and in fact we're only talking about these third numbers here, right? These numbers here, is we're going to make a value, and we're going to call it, let's call it smallest. And some people call it like temporary smallest or something like that. But I'm going to set the smallest value to the very first number. So I'll say 282.3. Now, the chances that the first number in a list is the smallest number is pretty slim. But I've got to start with it somewhere, okay? Then, after I declare that, I'm going to do my for loop. And I'm going to loop through each one of the data, and I'm going to ask a question using an if statement. So basically, I'm just going to ask, is it smaller than my current smallest? And if it is, then I will reset smallest to that. So I'm going to ask, are you smaller than my smallest value? Because if you are, then you get to be my new smallest. So we would read that number and we'd say, no, it's not smaller. No, 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 no. There it is, a new smallest value, 267.1. So we are going to change that number there. So my new smallest value is 267.1. Then we'll keep reading. No, 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 no. And it'll go like that. So let's try and do that. I am going to ask you to again take an opportunity to try and write that. Okay? Remember, we need to first create a variable for the smallest value, and it should be equal to the first item in the array. That's from get 0. Then you can do your loop. Now, technically, you might as well start your I at 1 instead of 0, but you can start at 0. It's fine. And you want to find the smallest value you can by continuously swapping out. Okay? Give it a try. All right, let's go over several different solutions for this. I'd like us to explore several different ways to do this. So first, I'm going to start with a variable called smallest, which will be equal to driving distance, or no, sorry, driving data dot get 0. Don't try and guess a number there. Don't try and put in 00 as the smallest or something like that. You don't know. So your first guess should always be the first item in the list. Okay? Then what we're going to say is for int I equals 0, I less than driving data dot size, I plus plus. And there's lots of ways you can do this. The first thing we could do is we could actually get like the value like this. We could say driving data dot get I. So so now val is stored as the ith data item. We can write an if statement and say if the value that we just got is less than smallest, then smallest will become value. And so each time it's going to get each value. It'll get val will be one at a time. Every value in that list. It'll ask if value is less than smallest, and if it is, we'll set smallest to that value. We're changing it, and then we can do system.out.println the smallest value. But that's the key, is that it's asking, hey, this value I'm at right now, is it smaller than the current guess at the smallest? And if Java says yes, it is, then remember the assignment goes this way from right to left, and we're going to write over what used to be here with val. That's one way to do it, by making this separate variable. You could avoid this and instead just take driving data.getI and put it right here. If driving data.getI, the ith value in driving data is less than smallest, but then you have to put it there as well. Which is fine to do that because it's still the ith item in the list. Okay, so that condenses it a little bit. I'm going to show you one more way to do this. The math class has a lot of different static methods that are really helpful. So let's go to our interactive shell together and let's look at some math class methods. We know that the math class has math.squareRoot, which always returns a double, even when it's a perfect square. If it's not a perfect square, it'll estimate it, right? There is also math.pi. It's a constant. These are all static, so you call them on the name of the class. There's math.pow, which is a way to raise something to a power. That's 5 to the second. Here's 5 to the third. These are all doubles as well, that they are returned. There's also a really nice method called math.min, which takes two numbers or two doubles and returns the smaller of the two. So we have that. And we also have this, which returns the bigger. So what we're going to say is we can say smallest is equal to math.min between the smallest value and driving data.getI. So what this will do is, if we go back to how we did this before, so it would start with smallest, which I'll call S, at 282.3. And then each time it's going to reassign smallest. Every time it's going to call smallest with these two numbers and ask the min function, what is the minimum, the smallest number between 282.3 and 300.3. And in this case, the number that was currently smallest is still the smallest. Now, some people find this a little bit difficult to understand, but this is actually really preferred. The direction that Java's programmers are going is to use less ifs and especially less loops even. That's even more advanced. Now, of course, it's still using if statements and loops. They're just embedded in the code. But because the math.min simply does what we did, it does an if statement. But by saying math.min, it's what we call like internal commenting. It makes your code so readable. Somebody looks at this, even without looking at the method name or the variable name smallest, they just automatically can sense that we're looking for a small value. Let's compile and run. Oh, I forgot to tell you that I commented out print average distance and replaced it with print smallest distance in my main method. You could run both, of course, if you wanted, but I just wanted one line. And you can see 264.3 is the smallest. What I'd like you to do now is to write a method that prints the largest distance, and I want you to use math.max instead of an if statement. Try not to look at this code. Obviously, if you look at this, it'll probably tell you exactly what to do, but try and do it from memory. Okay, so here is my solution using the math.max. So we start largest at, oops, I wrote get I, sorry. We start the largest, our guess at the largest drive is the first number in the list. We will then continue to loop through the entire list, each time having math.max return the larger of the two numbers between the current largest and the ith item. So if we started with this data, largest would begin at 282. And then it would be set to 300.3, which it would stay that way, stay that way, stay that way, stay that way, go to 312. 312, 312, 312. Like each time we're returning the max between 312 and 293 is 312. 312 and 285 is 312. And so I think out of this list, 312 would be the highest. But that's probably not the longest out of all of them. Let's print the largest as well. So I'll say gs.print largest. Is that what it's called? Largest distance? Yeah, largest dist. And we will run that. And 337.8 is the largest average distance. All right, good to go. Now, that is how we could handle some interesting statistics about driving distance. And it all started with us making a list called driving data and then adding our driving data. Driving distance happened to be the second to last item in the array that when we split. So when we made an array from the line, remember we split it. So it made this into, in fact, let me show that. Let's take Aaron Wise, and I'll do the interactive shell. We had something like that, and we said dot split. And, oops, I forgot the space. Python, it does it automatically, and I always forget that in Java it doesn't. You have to tell it space. And so that makes a list here. Let me bring it into the, come on. So that you can see that it made an array list, okay? Size 4, so index 3 was here, here, and here. Now, in order to get a specific value as an integer or a double, we had to use Double.parseDouble. It's a static method in the double class. I kind of wish it was in the math class, but it's not. And then we could say whatever our list was, which for me here, it's called string1. And then we need to do string1.length minus 1. That would get me the putting. Okay, it's string 1. I misspelled it here. So that would be get parse as a double the item in string 1 length minus 1, which means the very last number. And that's exactly what we had, negative 1.669. So what I'd like you to do now is I'd like you to please make an array list for the putting data. I want you to add it so we have both driving and putting data. And I'd like you to write a method that prints the largest strokes gained putting, smallest strokes gained putting, and the average strokes gained putting.